force will be zero on a closed path, always. What will be a non-conservative force? So, if this is a conservative force, what will be the definition of non-conservative force? Depends on the path taken. A force that depends, the work that done by a force that depends on the path taken, on the distance, will be a non-conservative. Why it is important and why I am introducing this term again? Because every time that you have a conservative force, there will be a potential energy associated with that force. But if it's a non-conservative force, there is no potential energy related to that force. Now, let me just give an example. Let's say that we have this system here, and I bring this from here to here. How much work I will exert to go from here to here? What will be the work done? Let's say the gravity. If I am doing work, the gravity is doing work, right? What will be the work done by the gravity going up the incline, which is here? What is the work done by the gravity by definition going up the incline? So will be positive or negative? Negative. So the work to go from here to here will be from here to here, will be negative mg delta y. Is that correct? Now, if I want to go from here to here, what will be the work done by Fg? By the way, because this is an inclined plane, what is delta y equal to? Good. Negative mg delta x sine theta. Because it's an incline, going up, which is this situation. Going up, negative, but remember that if it's an incline, delta y will be delta x sine theta. Going down, what will be the work done by the gravity? Mg delta y equal positive mg delta x sine theta. So, going up and down, what will be, which is a closed path, what will be the work? What will be, when you are adding this to work, what will be? Zero. So my question is, according to the definition that I gave of conservative or non-conservative force, the work done by the gravity, or Fg, the force of gravity, is conservative or non-conservative? According to the definition I gave, is conservative. Because the work on the closed path is zero, first of all. Secondly, if you go to the formula of the work done by the gravity, it's negative mg delta y. What is y? This is my y initial, and this is my y final. My question is, in the formula, negative mg delta y, this is mg, which is m is constant, g is constant, and y final and minus y initial. As we said, the work done by a conservative force depends only on the initial and final position. So if you go to here, to this formula, you can see that this is negative mg y final minus y initial. On what depends the work done by the gravity? On the initial and final position. That's it. So the formula is very clear. Is this conservative or non-conservative? Conservative. So, because this is a conservative force, there will be a potential energy associated with that force. Because only potential energy will be associated with conservative force. Got it? So we have to get gravitational potential energy at any point because this is a conservative force. Good. So knowing that, let's see the friction. I have the same object here. I move up. What will be the work done by the friction according to the definition? So we know that the friction will be going up. What will be the work done by the friction? Negative F by what? delta x. And delta x is the distance to travel from here to here, correct? Good. Delta x, which is d. Going down, what will be the work done by the friction? Negative f delta x. When you add it, this is 0. Is this 0? Negative fd plus negative fd. What do you get? Negative f 2d. And what is 2d going up and down? What will be negative 2d? What is 2d? The path taken. Right? D and D. Is this? So this depends on the path taken, clearly. Is the friction conservative or non-conservative? Non-conservative force. That's the definition of conservative and non-conservative force. My question now, will be any potential energy associated with the force of friction? No. We never will say, find the frictional potential energy. This is, I mean, you are just destroying the physics. Einstein and Newton will do like this, and you know, when you say find the potential energy for the friction. No, it's only associated with a conservative force. And the only force so far we learned, conservative, I mean, is the gravity, because that's the only one that we have the work dependent only on the initial and final position, not on the path taken. Knowing that, we now want to find what is the work done by the gravity, or what is the potential energy gravitational. Now we finish with the topic of a conservative and non-conservative force. What is a conservative, what is a non-conservative? An example of conservative at this moment, only gravity. Knowing that, let's find what will be the change in potential energy due to the gravity at low altitude. At low altitude, when the gravity is constant. By definition, I said that the delta U is equal to the work done by the external force when we are moving an object at constant velocity. So if we have the work done by the external force, we are able to find the change in potential energy. In this case, we want to find the change in potential energy gravitational. Delta U gravitational. So if I am moving this object from here to here at constant velocity, what is the external force on the object? What will be the external force acting on this object? My hand. So my hand is what we call external to the object Earth system. So if the system is object and Earth, because remember, the potential energy is the energy due to the relative position between two particles. Between two particles. So what are the two particles here that create potential energy? The object and what? The Earth. If there are no two particles, we can